So here we are, a small country affected by some kind of virus or other. Let's see if Newton-Raphson can come to the rescue of this country. So when we read the question, we need to read the question carefully because it tells us that I represents the number of thousands of people infected at time t. It doesn't actually say what t is, whether it's hours, days, weeks, or whatever, but that's not relevant really as far as the rest of the question is concerned. It's more important to understand that I is the number of thousands of people. So if we look at the two times which we're given, t equals 57 and 58, when t equals 57, I is this rather nasty looking expression. That's 1.053, so slightly bigger than 1. And when t is 58, I is slightly less than 1. So because the function is also continuous, then between t is 57 and t equals 58, I must be equal to 1. And therefore, 1,000 people must be infected between t equals 57 and t equals 58. So now we're applying the Newton-Raphson process once with an initial approximation of t equals 57. Now Newton-Raphson, what we're trying to actually solve is this equation here, 0.2 plus 0.01, etc. This thing, which is I, equals 1. So we're trying to solve the equation I equals 1. But Newton-Raphson relies on us starting with a function f of x, which we're trying to make equal to 0. So we need to rearrange this to make it equal to 0 by taking 1 off each side, and then the f of x, which we're going to use in the Newton-Raphson process, will be this function here, which we're wanting to make equal to 0. So there's the f of x that we're going to use in the Newton-Raphson process. We'll need to evaluate f of x at this initial value, t equals 57. So that's what f of 57, and I've given 5 decimal places there. But we'll also need value for f dashed x. We need to differentiate f of x. So when we do that, we differentiate f of x, this term will disappear, and then differentiating this is basically the product rule, the product of 200t minus t squared and 0.01 e to the minus 0.08 t. So we're using the product rule. So when we use the product rule, that term disappears, as I said, and then the differential of this is that. We multiply that by the other factor, and then the differential of this is that, and we multiply that by the first factor. We don't need to simplify that, but we do need to evaluate that at x equals 57. So f dashed of 57 is this horrible thing, which is that number there. So not actually that different to the number here, apart from the fact that it's negative, of course. Okay, so now we can use Newton-Raphson. So the improved approximation, improved on the value of 57, will be 57 minus f of 57 over f dashed of 57. And when I put the unrounded versions of these numbers into that formula, I get 57.89 as the value of t when 1,000 people will be infected. Okay.